Okay, so this one is about graph coloring, literally, but you need to turn the graph, you have to turn the map into the graph. And so the way I do this, you can actually draw directly on top of the map if you are very, very neat. You have to be very careful. And I say this because if you're sloppy, then I will not be able to read it, and I will not be generous in that case. So I put a little, let's say, pretend like you're making a capital city for each of these countries. All right, and then what I'm going to do is I'm going to connect the countries with every boundary between two countries is going to get an edge. You need to be very careful about this. It's very easy to forget somebody. So there's certain things that we normally remember. We connect all these guys along the shore, but then we do forget. The ones I'm doing now are not typically the ones that are forgotten. These guys are just kind of in a row. But any time there's a possibility of crossing from one country into the other, you have to look and say, is there a way to cross from this country to this country? For example, this guy, right here. There's a way to cross. He'd be easy to forget. Okay. Now here's one that's super easy to forget. This one right here. And let's see, this guy can cross over to here. Did we get everybody? I think we did. Now, you can just do this right in place if you want, or you can make another copy of this graph somewhere else if that helps you. Okay, now I'm going to put labels on some of these guys. So because we have triangles, first of all, lots of triangles, so 3 colors to start. Okay, for example, a checkerboard would not have triangles. A checkerboard would have this kind of pattern. You know, they would have neighbors on all 4 sides, but we would have what we call a bipartite graph, because we could color these guys with one color and then these guys with another color. We could just alternate. So if we don't have a triangle, we don't have the right to start with 3 colors. But most of the graphs we do deal with will start with 3 colors because we probably will have triangles in them. Okay, but what do? We're going to end up needing a 4th color for this. It's pretty common. So let's figure out how we could prove that we need 3 colors. Okay, so first of all, if we start in this vicinity, it's not going to help us much because we're just going to alternate, for example, black, white, black, white, black, white, and then the 3rd color would be this country. So we could go black, white, black, white. If we had this kind of shape, we might only need 3 colors. It depends on exactly whether it ended up being an even or an odd ring around the outside. But this is only a ring around the left side, so if it were just alternating, it wouldn't be a problem. And whatever color this is, let's say this is red, then this guy over here could be red too. So that's not a really strategic place to start the discussion. But we could go ahead and say maybe anchor the triangle here, maybe color A, color B, color C, and C again. Okay? So start with triangle ABC. It needs 3 colors. Then we can reuse color C at, let's say, point Q. Okay? So then what happens? Well, we could come down here and still use ABC, but we would have to use what? We'd have to put the B here, and we would have to use A over here. Rather, we'd have to use A here because we already have B and C. So then we'd use A prime at point P. Use color A again at P. Okay, I'm kind of mixing my notation, sorry about that. But then we'd have to use color C again. Color C at point R. At R. Have we gotten into a dilemma yet? That's a question. We are going to get into a dilemma, but when? Pretty soon, I bet. Okay, we're going to use B again. And we're going to call this point S. Color B point S. And then we have to use color A at point T. There's got to be a more elegant way to do this, but you know what? You're actually seeing how non-elegant this can be. All right. So we have, for example, we have color C going on here, color A going on here, and color B going on here. Maybe it's not a problem. Ah, there is going to be a problem though, because we missed one of the edges. This is why this is a problem. It's very, very easy to forget. And this can unravel all your work. So we can't use color A at point T. So luckily I have an eraser. I'm not going to use color A at point T. In fact, we've now found our contradiction because we have color A at point P, color R, or color C at point R, and color B at point S. Okay? And so we require a new color, and in this case we have a new color. So we needed 3 different colors at points P, R, and S. So let's call this point T. So point T, which touches them all, needs another color. All right? And from here, now you've got your 4 colors. Now you can just go ahead and use them. So the hard part is establishing that you can use, or that you can demand the use of that many colors. And, well, my notation was sloppy, but I'm coloring point A, color A, and point B, color B, and point C, color C. And then after that, when I start recycling them, I have to use a different name for, let's say, the country or the point and the color. I have to start using different names, because when I say, what does it mean to use color A over here at point U, for example, it means I'm inheriting the color from country A. And like I said, we can just alternate these guys now. This guy's on the little edge here, no problem, we can just alternate the colors, and that's not going to cause a problem. And I don't even need to name them at this point. I only needed to color one country a different color to make this work. And it was, you know what, in some sense it was just due to the structure. Let me just sort of highlight this structure in here was causing the problem, something in there. But you know, you can't just point to one thing, because a lot of things could be adjusted to negate the need to do this. But for one thing, I feel suspicious about this little boundary here, because it brings point Q and point T close together. But we see, even if, well, we kind of did need point Q to make this happen, but it almost feels like we didn't, because we colored point Q a long time ago. But the coloring on point Q that we had from way back in the beginning affected all the colors we were able to choose down here. So it really did affect it. So anyway, the point is, you must justify each new color. Okay? but for K3 you have 3 colors, and K3 is a triangle. K4 you start with 4 colors. So if you can find a K4 graph, and K4 graph is not very fancy, it just looks like this. Okay, so you can find this structure, and of course this is a planar graph, so it's going to look kind of like that. If you can find this structure anywhere in there, then you almost have it here. You see, but we don't. We don't really have a K4 sitting there, but we're very close to having a K4 sitting there. Okay, so yeah, all right. Just be careful. Justify each new color, and if you can find shortcuts, take them. But the shortcuts are, if you have a triangle or K4, you can start with that many colors.